Good afternoon, class. In today's video, what I wanted to do is start a series of videos on how to do electric field problems, more specifically, how to answer the question, where is the electric field zero? So in this one, I'm doing an example problem from the electric field problems, problem number 2. So if you want to follow along using the file, then that's fine. So in that one, Q1 is 1 coulomb, Q2 is 2 coulombs. We have our electric constant K of 8.99 times 10 to the 9th Newton meters squared per coulomb squared. Our total distance between the two charges is 1 meter. And then, so really what we're looking for is this R1 is question mark meters. Now, some of you might say, wait, Mr., where does this R1 come from? Because it seems like you just made up a variable. And the answer is, technically I did. And the reason why that's the case is because the question is, where is the electric field zero? But I already told you the total distance. So this value is known. However, the value that's not known is where the electric field is zero. That's why I had to name it a new variable, which I call R1. And of course, short of just asking you to believe me as if I'm just making this up, I drew a diagram to show you what I'm talking about. So in my diagram, I've got two charges, Q1 and Q2, and there is a distance between them, R1 and R2, where the electric field will be zero. And you can probably see that because you've got electric fields coming out this way and electric fields coming out this way. So there's going to be a point when they clash. And when they clash like this, they cancel each other out, and so you get a net electric field of zero in that area. Now, it could be here, directly in the middle. It could be a little bit more towards Q1, a little bit more towards Q2. It really depends on the specifics of the problem. So in this case, what I'm going to do is I'm going to start by doing all of this, and I'm going to start, and this way this video looks a little bit, or this problem looks a little bit more in depth. And the reason why it looks a little bit more in depth is because I'm actually going to solve this problem generally first, and then at the end I'm going to actually plug in all of the values that are going to work. This will be a series of videos where first I'll solve this problem using the quadratic formula. Then I will do the trivial case of where Q1 and Q2 are equal, and then I will solve another one using the method of completing the square, so that you have an idea of how this works and where then at least you'll have two different methods of solving this, so that you can look at a problem like this and go, okay, it's not easy, but it's not so impossibly difficult anymore. So I have this here. I even highlighted the actual, the generalized formula for how to solve for it. So if you're like, well, I like this explanation, that's fine, that's all well and good, but I just want the actual formula, then it's right here in green. So if you ever want to just like pause this video and just write this one down, plug in your values and solve, that is okay as well. I'm doing this part is more for the mathematically not inclined, but the mathematically curious among you who actually want to see where I actually got this. So here we go. What I'm going to do is my equation is going to be, in order to answer the question, where the electric field is zero, in order to even understand that means I need to add up all of the electric fields, and then I'm going to find when the electric fields combine, sum together or add together, and they form zero, that's the location. That location is what is my answer to the question. So I'm going to use this formula, sigma E with a vector notation on top equals 0. So keep this in mind. This is the Greek letter sigma, and it means summation of. You'll see this in your math classes later on in the future. So sigma E, or sum of E is equal to 0. This means that that electric field of Q1 and plus the electric field of Q2 is 0 somewhere. We don't know yet, but we're getting there. Now, here's the thing. So when I write this out, I have kq1 over r1 squared plus kq2 over r2 squared. Why is it r1 and r2? Because I don't actually know what these distances are. All I know is that the total distances are, but where that is 0, I actually don't know. So I've got these two variables that r1 and r2, that I don't know about. So this, and don't get me wrong, I have one equation and two variables that I don't know. This kind of freaks me out for a little bit until I allow for a condition that will help me solve this. Because otherwise, I'd say two variables, one equation, I can't get a unique solution from this. So that would be a problem, but I have a workaround, but we do need to define a couple of things, especially because this is a vector. So in order to really solve this, first I need to know which way is positive. And then I need a relationship to get me R2, to relate R2 and R1 and bring them together so that I can actually add them. So I'm going to define that to the right is positive, to the left is negative. So that's why I have this arrow here. So let to the right being positive, and now I'm going to also say let R2 equal this total distance R minus this distance R1. Okay, so hopefully you can see if I have this R minus R1, I've got R2. Okay, so once we do that, I can rewrite this equation as kq1 over R1 squared minus kq2 over R2 squared. This is just this first statement over here. Now I'm going to add this statement right over here. So that means I'm going to get kq1 over R1 squared minus kq2 over parentheses R minus R1 and parentheses quantity squared. So one thing that hopefully you notice is that the k's cancel, so I actually don't need them in this equation. Now I've got, and also to save some space, because as you can see I've kind of filled this board up, not as much as some of my other videos, but this is a pretty filled up board. So I skipped a couple of steps. What I did was I added q2 over r minus r1 quantity squared to both sides of the equation, and then I cross multiplied to get rid of this fraction, but the result was I got q1 times quantity r minus r1 quantity squared equals q2 times r1 squared. So I did skip a couple of steps, so if you ever need to pause the video and actually fill in these steps, then just to show you, just to let you know, there are some math steps that go from here to here. So with that, what I did from here was I distributed all the q1s, and then I tried to gather all of the r1 terms together, because if I can gather the r1 terms and solve, then I can at least get the answer that I need in order to actually answer this question. So what I get is q1 r squared minus 2q1 r1 plus quantity q1 minus q2 times r1 squared equals 0. Now this is important, because what I'm going to do is, and you already know this, I'm using that quadratic formula to figure this out. But in order to do that, I need something that has the terms A, B, and C in it, and I'll define those as well, because I did so in red. Okay. Now, but one thing you might notice too is, well, where did this q1 minus q2 term come from? That's because I had q2 r1 squared over here, and I had q1 r1 squared over here. So that's where I gathered all of my terms, and then I factored out the r1 squared, because what I'm really trying to do is isolate the variable. So given all of that, that's how I got to this step. Then what I did was I moved r1 squared to the left side of the equation, because what I wanted to do was because I'm actually solving for r1, not r, because I already know what r is. That's already been determined. So then what I did was I divided both sides of the equation by q1 minus q2 to get me a 1 over here, mostly because it makes the quadratic formula a lot easier. Now, one of the things that you may have noticed here is, hey, wait, but mister, q1 minus q2 is in the denominator. So if they're equal to each other, doesn't that mean that this would be infinity, or at least it would be undefined as a more mathematically rigorous definition? It would be undefined. And the answer would be yes, it would be. That would be a problem, But this whole method that I'm doing only assumes that these Q1 and Q2 are not equal. If they are equal, then you go into the trivial case, which I will do in the next video. So given that, I'm going to, so what I did was, just to make this a little bit easier, because I've got the quadratic formula right over here, so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And for all of those of you who are in your math classes, if you sing out the tune of Pop Goes the Weasel to this formula, it should help you remember it. A little tidbit there. But well, of course, now what is this B? What is this C? What is this A? Those are good questions, and that's why I circled them saying A, B, and C. So in this case, I didn't write the 1 here because you don't need to, but I wrote it for you over here just to show you that 1 is A, and then negative 2Q1 R over Q1 minus Q2 is B, and then Q1 over Q1 minus Q2 is C. So wrote that out for you so that when I write it out over here, while this may look pretty scary, it at least is, you can follow along how I went from here to here. So I plugged in everything, and then what I noticed was I've got this big division bar, this big fraction bar all over 2. And I don't really want fractions as much as I can avoid it. So what I did was I saw there's a common factor of 2 over here, and then I know there's no factor of 2 over here, but I noticed that there's a 2 in here, and then there's a 4 over here. The thing is, this 2 is squared, and 2 times 2 is 4. So there's a common factor of 4 in here, and the square root of 4 is 2. So I actually do have a common factor of 2 in this term, a common factor of 2 in this term. So that's why when I put my general result, which I highlighted in green, I got rid of the 2 in the denominator, and then I got rid of this 2, and this 4. So that's where it went, in case you're wondering. So this is the general result of how to do something, of how to solve for R1 if the charges are not equal. If they are equal, you have to go, you can actually stop a whole lot earlier, because a lot of these things will go away, and you'll actually be able to solve for it. It's a very nice result, by the way. So, think about that for, in terms of how you're going to make this work. So now that I've actually done this general result right here, I can actually start plugging in all the information that I actually had up here at the top to actually give me my answers for R1 and R2. So I just plugged in all of my answers here, and what I do is I pretty much will give you some time just to take a look at this. You could have paused this video at any point to actually see this. Then I just did a bunch of algebra, and so I found that the only thing to note is that there's a plus or minus over here. There's a plus or minus over here, and then all of a sudden, I got rid of the minus over here and just left it as plus. Now you might ask, why did I do that? The answer is because R1 has to be somewhere over here, right? And we said it's positive. So if it is positive, that means it must be a positive distance away from Q1, which is to the right. So therefore, I have to look at this and go, okay, because if I said it was minus, that means it would be over here somewhere. And clearly, the point where the electric field is 0 cannot be over here when the second charge is right here, because there's no way the influence of both, because both of the influence of Q1 and Q2 is to push outward. So there's no way that this point would be 0. It can only be somewhere over here. So when I do that, that's why I got rid of this negative sign over here. So my answer would be square root of 2, or negative 1 plus the square root of 2 meters. And why did I leave it like this? And by the way, is this an okay answer to leave on like a test or something? And the answer is yes, of course it is, because this is an exact answer, whereas if you had tried to turn it into a decimal or something, you would be rounding it, and that can lead to some errors along the way. So if you're the only reason you would ever turn it into a decimal, though, is because there's a multiple choice test, and that's just one of the answers is listed there. So then that'll be fine. Otherwise, this is perfectly fine. And then, of course, what I did was I said, okay, here we go. So I've got R1. What is R2 going to be? Because I know R2, like we said over here, is R minus R1, which I wrote again. So I'm just going to plug in my values. 1 minus the 1 minus this R1 value, which is -1 plus square root of 2. And I get the answer is 2 minus the square root of 2. Is that a positive number? The answer is actually yes. And so if you add both of these up, what you should get is that this total distance, or R1 plus R2, should come out to the total R value, which is in this case is 1. So if you add that all up, you should get R, or 1 in this case. So, you know, now of course, to summarize, if you were looking at this whole video going, wow, I have to do this for every single problem, the answer is no. If you just take this formula, plug in your numbers, you only have to go from here to here to get your answer. So this would be the way to solve number 2 on the homework set for electric field problems. Next time I'll be working on the trivial case where the charges are equal, and then I'll work on completing the square afterwards. So good luck in your studies. May the force be with you.